We all take them, but what do vitamins actually do? Today, we explore the science of micronutrients, their vital roles in your health, and a simple overview to help you decide if supplementing is right for your lifestyle. So, what is a vitamin? Vitamins are compounds your body needs to function, but cannot produce on its own in high enough quantities, which means the only way to get them is through food, supplementation, and sunlight in the case of vitamin D. You have two types of vitamins that behave very differently once they get inside of you. Fat-soluble vitamins, A, D, E, and K, they dissolve in fat, which means your body stores them in fatty tissue and your liver. That storage capacity sounds convenient, and in some ways it is, because you don't need to consume them every single day. The problem is that the storage also means accumulation, and accumulation means that too much of a fat-soluble vitamin can over time push levels into ranges that cause real harm. Your body has no easy way to dump the excess. Water-soluble vitamins work the opposite way. Vitamin C and all 8B vitamins dissolve in water, circulate through your bloodstream, and get flushed out through your urine when levels run high. Your body keeps what it needs and discards the rest, which is why researchers coined the phrase expensive urine to describe what happens when healthy people take large doses of water-soluble vitamins they don't actually need. The upside is that toxicity from water-soluble vitamins is rare. The downside is that you can't stockpile them, so consistent daily intake matters. Now, here's what vitamins actually do once they're inside of you. They are not fuel. Vitamins do not provide calories or energy in the way carbohydrates, fats, and proteins do. What they do is act as enablers that make other biological processes possible. Some vitamins help enzymes do their job, triggering chemical reactions your cells depend on. Others act as antioxidants, neutralizing unstable molecules that damage cell membranes and DNA. Some play direct roles in building bone, producing red blood cells, clotting blood after an injury, or sending signals through the nervous system. Without enough of any one of them, support starts to break down, and we call that deficiency disease. Now, let's talk about the gap between deficiency and optimization. Here's where supplement marketing and human biology start pulling in opposite directions. Vitamins were discovered because of deficiency diseases, conditions so severe that entire populations suffered from them when food supplies lacked certain nutrients. The science behind those discoveries showed clearly and repeatedly that giving people the missing nutrient reversed or prevented these diseases. The evidence is rock solid, and it built the foundation for everything that came after. What supplement marketing did was take that foundation and extend it in a direction that science actually never supported. The logic went like this. If getting enough of a vitamin prevents a deficiency disease, then getting more than enough must produce even better health. More must be better, and with that logic and access to billions of dollars of advertising over decades, it turned vitamins from a medical tool into a lifestyle product. The body does not work that way. Most vitamins operate on a curve. Deficiency causes problems on one end, sufficiency supports normal function in the middle, and excess either gets excreted harmlessly, or in the case of fat-soluble vitamins, accumulates in ways that creates new problems. The sweet spot is in adequate amounts, not abundance. Getting enough vitamin C keeps your connective tissue intact and your immune system functional. Taking 10 times the recommended amount does not give you 10 times the immune function. Your cells have receptor limits, absorption limits, and processing limits that cap how much of any given nutrients they can actually use. This is also why the research on supplements gets complicated fast. When you study a population with genuine vitamin D deficiencies and give them vitamin D, you see real benefits, because you're correcting a real deficit. When you study a population of well-nourished adults with adequate levels and give them the same supplement, the benefits disappear, because there was no deficit to correct. The supplement industry sells to both populations with the same message, and the same science applies to them very differently. So, who actually needs supplements? The evidence on this is cleaner than most people expect once you stop asking, do vitamins work? And you start asking, do vitamins work for me? Deficiency is more common than most healthy adults realize. A 2023 global analysis drawing on 7.9 million participants across 81 countries found that nearly half the world's population falls below adequate vitamin D levels. In the United States alone, 41.6% of adults are deficient in vitamin D, with rates climbing to 82.1% among Black Americans and 69.2% among Hispanic Americans. People with darker skin produce less vitamin D from sunlight exposure because higher melanin levels reduce UV absorption, and anyone spending most of their time indoors, regardless of skin tone, face the same challenge. Vitamin B12 deficiency affects 10 to 15% of adults over 65, and the reason comes down to digestion rather than diet. Absorbing B12 from food requires a protein produced in the stomach called intrinsic factor, and the stomach produces less of it as people age. People taking metformin for diabetes face a 22% deficiency rate because the medication interferes with the B12 absorption directly. Combine metformin with long-term use of acid-reducing medications, and that rate reaches 34%. None of those people are making a lifestyle choice when they supplement, they're filling a gap their biology created. Strict vegans and vegetarians face a genuine B12 challenge because the vitamin exists almost exclusively in animal products. No plant food contains meaningful amounts of it, and that's not a matter of eating better or more varied plants, it's a structural limitation of plant-based diets that supplementation or fortified foods directly address. Pregnant women represent another clear case. Iron deficiency climbs from under 7% in the first trimester to over 28% in the third, and the World Health Organization recommends iron supplementation for all pregnant women as standard practice. Folic acid supplementation before and during early pregnancy reduces the risk of certain serious birth defects by more than 70% in clinical trial data, which is why health agencies across 71 countries recommend it. Beyond those groups, the picture gets murkier, and that's exactly where $60 billion a year goes. So, what the research actually found. The largest clinical trials ever run on vitamins produced results that surprised almost everyone, including the researchers running them. The pattern that kept appearing across multiple large studies was this. When scientists isolated a single vitamin and gave it in supplement form to people who already had an adequate nutritional status, the benefits that observational studies had associated with that vitamin in food simply did not show up. Worse, some trials found that certain supplements in high doses moved outcomes in the wrong direction. The antioxidant story is probably the most striking example of this pattern. Foods rich in antioxidants, fruits, vegetables, whole grains, consistently correlate with better health outcomes across decades of population research. That correlation drove enormous enthusiasm for antioxidant supplements, and billions of dollars followed. Multiple large trials testing their supplements in isolated, high-dose form found not just zero benefit, but in several cases, increased rates of the very diseases the supplements were supposed to prevent. Researchers offered an explanation for this that became known as the food matrix effect. A piece of fruit contains thousands of interacting compounds, fiber, polyphenols, enzymes, water, that alter how its nutrients get absorbed and used. Blood orange juice demonstrated greater antioxidant activity in the body than sugar water with equivalent amounts of isolated vitamin C added to it. Even though the vitamin C content matched, stripping a single compound out of that matrix and concentrating it into a pill changes how the body responds to it in ways that are not always predictable and are not always beneficial. Beyond the food matrix question, your body's own antioxidant systems are tightly regulated. Your cells produce their own antioxidant enzymes and maintain a careful balance between oxidative processes, which the body actually needs for certain functions, including immune response and protective mechanisms. Flooding that system with high-dose antioxidants from outside can interfere with the balance rather than improve. None of that overturns the evidence supporting supplementation for people with documented deficiencies. What it means is that the same pill does different things depending entirely on the person taking it, which leads us to this. The quality problem that nobody is talking about. Even if you have identified a genuine need and found the right supplement, there is a separate question that the industry would rather you not ask. Is what's on the label actually in the bottle? In the United States, supplements are regulated as food rather than drugs, so no pre-market approval for safety or effectiveness is required before a product hits shelves. A manufacturer can formulate, label, and sell a supplement without ever submitting evidence to the FDA, or that its contents claim to contain the correct dose it states on the bottle. The FDA can take action after a product reaches market if it receives evidence of harm, but the burden of proof runs in reverse compared to pharmaceutical drugs. A 2018 analysis of FDA warning records found 776 supplements containing pharmaceutical drugs that were not disclosed on the label. Products marketed for weight loss contained a prescription drug that had been pulled from the market years earlier over heart risks. Products marketed for sexual enhancement contained active drug compounds. Bodybuilding supplements contained synthetic steroids. 1/3 of those flagged products remained available for purchase 6 years after the FDA identified the problem. Independent study organizations exist to address this gap. Consumer Lab and NSF International run a certification program used by professional sports leagues. They conduct third-party testing and publish their results. A supplement carrying a verified seal from one of those organizations has at least cleared the quality threshold. However, that verification does not speak to whether you need the supplement. What it does tell you is that the pill contains exactly what it says on the label. The most useful thing science points towards is this: talk to your doctor, get your blood work done, and do your research. Find out what your levels actually are before spending a ton of money on supplements chosen based on what sounded good on an aisle at the grocery store. The biology of vitamins is not complicated. Your body needs certain things to function. It can't make it itself, and it gets them from food or it gets them from supplements. What determines whether a supplement belongs in your routine is whether the food is already fulfilling your supplementation needs. If you enjoyed this video, please hit that like button. And to stay up to date on my future videos, please consider subscribing. I hope you're all happy and healthy. Thank you.